Alrighty, 632.8 nanometer laser has an incident angle of 45 degrees in the air. Strike some oil with an index of refraction of 1.54. What is the frequency of the laser? Okay, so I'm going to find the frequency for A. I'm going to use V is F lambda, so therefore frequency is V over lambda, which is the speed of light, because it's light, right? And then that's divided by lambda, which is 632.8 nanometers is times 10 to the minus ninth. Okay, so this is going to be a big number. So let's see, 3E8 divided by 632.8 times 10 to the minus ninth. That's 4.74 times 10 to the 14th hertz. All right. So that is our frequency. That's 4.74 bugala hertz, right? What is the wavelength of the laser in the oil? Well, there's two ways to do this. One way is to figure out what the velocity is in the oil, right? So the velocity in the oil is going to be 3.00 times 10 to the 8th divided by 1.54 is equal to, divided by 1.54, that is 1.948 times 10 to the 8th meters per second, and then I could divide by that frequency. So divided by that frequency, and I get, so this divided by that, I get the wavelength in the oil for B, right? Wavelength is velocity divided by frequency. And so if you do this velocity divided by that frequency, you get 4.109 times 10 to the minus 7. So that's 400. So 4.109, or it's 411 times 10 to the minus ninth, or 411 nanometers, right? But you know what? I can get the same thing by just simply going 632.8 divided by 1.54. So take the ratio, basically the index of refraction of air is 1.00, right? And the ratio of those, if you just divide by that, in other words, this times this divided by that. Let's try it. 632.8 times 1 divided by 1.54, and you get 411 nanometers, right? So that's what I would do, okay? And then it says, C says, what is the refracted angle in the oil, right? So we're going to go N1 sine theta 1 equals N2 sine theta 2. So 1.00 sine of 45, right? So this index of refraction goes with that angle, right? Is 1.54 sine of theta. That's going to be theta in the oil, okay? So I'm going to do the inverse sine, so second sine of this times this divided by this. So 1 times sine 45 divided by 1.54. Now keep in mind that I just checked my mode, I'm in degrees, okay? And I get 27.3 degrees. So theta in the oil is 27.3 degrees. That makes sense. All right. And then D says, what is the critical angle? So the critical angle, we're going to do exactly the same thing. We're going to go N1 sine theta 1 is, for the critical angle, it's going to be N2 in this case, this is the slow medium, right? So what it is that it can't get out of the oil into the air, right? So I'm going to make this 90 degrees, so 1.00 sine of 90 degrees, because the 90-degree angle is going to happen in the air, right? And that means basically it can't escape, okay? And then N2 is going to be 1.54 sine. In this case, it'll be the critical angle, Okay? So basically it's the inverse sine of 1 times 1, which is 1, right, divided by 1.54. So the inverse sine of the ratio of the indices of refraction. In this case, it's 1 and 1.54. So the critical angle is the inverse sine of 1.00 over 1.54. You can't get it wrong. I mean, if you try to do the reciprocal of that, you'll get a domain error, right? So inverse sine of 1 divided by 1.54, and that's 40.5 degrees. And it always happens in the slower medium. Okay, you can always get from a faster medium to a slower one. You can't always get from the slower one to the faster one. Okay?